Okay, here's a mesh current problem where we have something we haven't seen in a problem like this before yet, and that's right here where this current source is. There's two mesh currents defined through it. We did see a case where there was a single mesh current defined through a current source, and in that case, that single mesh current is just equal to the value of the current source. Okay, but here we've got something different because I1 and I2 in this particular problem are both defined through this 2 amp current source. Okay, so when you have a problem like this, you need to define a voltage across the current source, and it's arbitrary how you define the polarity, because remember, if polarity of a voltage is really opposite of how it's defined, well, we just show that with the negative sign in front of the voltage. So I'm just going to say that the voltage across this current source has the higher end on top, and I'm just going to use a variable VCS, okay, which represents the voltage across the current source. Okay, so voltage across the current source. Okay, so this is mesh current method, so I'm going to start with a KVL equation for mesh current I1. So starting where the 30 volt source is, I'll have 30, right, 30, and then minus 1 times I1, and then minus the voltage across the 2 amp current source, which we're going to use variable VCS. Okay, so that's my KVL for I1, and then KVL for I2, okay, is I'll have VCS, voltage across the 2 amp current source, then I'm going to have minus 2I2, and then minus 4I2. Oh, and I forgot to have this summing to 0 here, right? Because KVL sums to 0. Alright, so you can see that after we write our KVL equations, and because we have this extra variable here, which is the voltage across the current source, well, look, we need another equation, right? Because we have two equations and three unknowns. Our unknowns being I1, I2, and VCS. Well, the way you get your third equation, okay, your extra equation, is that you look here at the current source, and again, you got to remember what this symbol tells us. This symbol tells us there's this amount of current, which is 2 amps in this case, flowing in the direction of the arrow, so flowing up. So since there's two mesh currents defined through this current source where we know there's 2 amps, and these mesh currents are going opposite directions through this current source, well, it tells us that the difference between I1 and I2 has to be the value of this current source of 2 amps. So now the question becomes, well, is it I1 minus I2 is 2 amps, or is it I2 minus I1 is equal to 2 amps? Well, the way you tell is you look at how the direction of the mesh currents compares to the arrow, the direction arrow of the current source. See, I2 is defined in the same direction as this current source direction, so that's the positive one, and I1 is defined against the arrow of the current source, so that's the negative one. So you see, it's not I1 minus I2 equal to 2 amps, it's I2 minus I1 is equal to 2 amps. See, that's our third equation. Okay, I2 minus I1 is equal to 2 amps. So now you have your three equations and your three unknowns, and you can go ahead and solve.